We'll start with the discussion of the pop quiz. This was MCQs Pop Quiz 19. If you have any doubt, question one. Question number one, basically what you have to do, you have to understand that for especially for the organic reactions, what are the product a substance can form. Um, which reagent will react with pentane 3-ol to give stereoisomers? So stereoisomers are what? Stereoisomers can be geometrical or it can be optical. Okay. So if we have a pentane 3-ol and it react with acidified potassium dichromate. So we have to check whether it might result in a geometrical or an optical isomer. First, what will the product, because it is an oxidizing agent, the oxidizing agent pentane 3-ol. So what it will, this is a pentane 3-ol. Pent means 5 carbon and OH is attached with the second one. This will have 2 hydrogens. This will have 3 hydrogens. This will have 2 hydrogens, and the last one will have 3 hydrogen. So it's a secondary alcohol, and secondary alcohol will be oxidized to ketone. Means when oxidation happen or occur for this secondary alcohol, what will be the product? The product will be a ketone. So it will be C double bonded with O here. So if it's a C double bonded with O, and now we want to check whether it is a stereoisomer. Stereoisomer can be optical or geometrical. If it's a geometrical, there must be a carbon-carbon double bond. If it is an optical, the carbon should be bonded with 4 different groups. Then it will be an optical isomer. So when we check, as a product is formed, none of the carbon, like this is not a chiral center, this is not a chiral center because 2 hydrogens are attached. This one, when there's a double bond with oxygen, it cannot be a chiral center. This cannot be. So A is not the possibility. What about B? If we are using a concentrated sulfuric acid, so what it might result? So if it is a concentrated sulfuric acid, it alcohol, the elimination reaction happen or occur. So as a result, if elimination reaction happen or occur with phosphoric acid or with sulfuric acid, so the propane, so if it is a propane 2-ol, a propane 3-ol, the OH is attached here. So this OH will be lost and one of the adjacent hydrogen will be lost. So as a result, what it will turn? It will turn into alkene. And this will have one of the hydrogen being lost. This is CH3, this is H here, and this is CH2 and CH3. So because the possibility is there, it will form it will have a carbon double bond. When there's a carbon double bond, so this hydrogen might be here, C2H5. The collectively this is C2H5. This hydrogen might be here and CH3. So the heavy groups can be on the opposite side. So what it might result? It might result in a presence or formation of a geometrical isomer. And stereoisomers can be geometrical or it can be optical as well. That's why B is the right answer. Same way what you have to do, if it react with ethanoic acid, and alcohol react with acid, it will form a ester. And to check whether the stereoisomers are possible, you have to check if it is an optical, then 4 different groups should be attached to a carbon. If it is a geometrical, then there should be a carbon-carbon double bond. Is it clear, this one? What about D? If HCl is there and it is reacting with, if you have an HCl and you have an alcohol, because the OH is attached here at the center. So this OH will be replaced by Cl when the reaction happen or occur. So it won't form a chiral carbon. Why it won't form a chiral carbon? It cannot be geometrical because there is no double bond here. When it will react with hydrogen chloride, this OH is replaced by Cl. But is this carbon is a chiral carbon? No, it won't be a chiral carbon. Why? Because C2H5 here and C2H5 here. So identical groups are attached. So this cannot be a chiral carbon. So it won't form the stereoisomer with the fourth one. It will only form with the when alkene is formed. With phosphoric acid and sulfuric acid, there will be elimination reaction. Sulfuric acid is also known as a dehydrating agent. Dehydrating agent means it has a tendency to remove the water from the substance. Question 2, any doubt? From next week onward, we will start doing the past papers for both Cambridge and edexcel. Separately, we'll do the past paper, and I will mention which past papers we will discuss because some of the students were asking when we'll start a past paper. So from next week onward, we'll have a regular session for the past paper. So next week I plan like we'll start our sessions with the unit practical questions for both edexcel and a Cambridge, and then doing the past paper from different years. So you will have a better understanding of the topics because we are done with a revision one time. Question 3, 4, any doubt? Question 5, any doubt? Question 6, okay. In question 6, which statement describes which statement describe what happened when 2-chloro-2-methyl propane is warm with sodium hydroxide? About the past paper discussion, yes, I will mention at a week prior to that, like I will mention which past paper I will discuss next week, so you can do it by yourself and you can ask your doubts as well. But I'll try to solve every question, every part of the question, and you can also annotate on the screen during those sessions. So which statement describe what happened when 2-chloro-2-methyl propane is warmed with the sodium hydroxide? So we have prop means 3 carbon are there. Second position we have a chlorine, and the second position we have a methyl group. Look, what kind of a halogenoalkane is this? A carbon is attached with a halogen. It is having 3 carbon chain. So this is a tertiary halogenoalkane. And tertiary halogenoalkane, what kind of, they have a substitution reaction, SN reaction, but what kind of substitution reaction? SN1 reaction will happen. And with aqueous sodium hydroxide, it is a SN reaction, but with alcoholic sodium hydroxide, it is an elimination reaction. So what will happen? What kind of reaction? This is a tertiary halogenoalkane. So react mostly by SN1 mechanism. So C will be the right answer for this. Question 7, any doubt? Question 8. Question 7, there's a doubt? Okay. If elimination reaction happen, it will form alkene. If a substitution, then it will result in a formation of alcohol with sodium hydroxide. So sodium hydroxide or potassium hydroxide can react in alcoholic medium which result in elimination reaction form an alkene when halogen alkanes are the reactants. And when sodium hydroxide in aqueous medium reacting with halogenoalkane, it results in a formation of alcohol. How many structurally isomeric secondary alcohol? Secondary alcohol means like a carbon is bonded with OH and only two carbon chains are around. That is a secondary alcohol. With a molecular formula of C5H12. So means this is fixed. I can only change because I want to make a secondary. If I want to make a secondary, the only thing what I can change is the carbon, like the around it, the number of the carbon. So if this is having one carbon and this is having, because it is C5, so if this is having five, this is one possibility. I'm not drawing the hydrogens. These are representing the hydrogens. So this can be hydrogen. This is one possibility because this will be we want a secondary alcohol. Secondary alcohol means a carbon bonded with OH should have a two carbon chains around it. Then what is another possibility? If I want to draw, as it's a constraint that we have to draw a secondary. So we have 1, 2 here and 1, 2 here. So this is a second possibility because these are also tertiary. As a carbon is bonded with a OH, it is having two carbon chains around it. So this is also. What about the third one? I cannot change like one side 1, another side 3. That will be same. So what else can be done? I can make this as a branch as well. Like I can rearrange this. So COH is there. The first structure I will just rearrange to make the branch carbon because constraint is we have only 5. So 1, 2, 3, 4, and then I put a branch here. That is one possibility. So how many possibilities are there? We have only 3 possibilities that we can arrange in a secondary alcohol. Secondary alcohols, all of them are secondary alcohol and they are all isomers of each other. So the correct answer for this one will be C. How is the secondary not tertiary? How is the secondary not tertiary? What you have to do, the carbon which is bonded with OH, you have to check how many carbon chains are around it. So this is one carbon chain and this is a second carbon chain. So this is a secondary. When you check this carbon, this is one carbon chain. This is a second carbon chain. That is also secondary. This is one carbon chain and this whole, the whole chain is the count as one. So this is also secondary. Question 8, any doubt? How we can distinguish between an aldehyde and a ketone? Question 9. Question 8 is a doubt, okay. In question 8, which reagent can confirm the presence of a carbonyl group in organic compound and does not distinguish between an aldehyde or a ketone? Like we can say that there's a carbonyl group, but we cannot distinguish whether it is an aldehyde or a ketone. Acidified potassium dichromate. Like because what we want to do, we want to acidified potassium dichromate. It can react with, this is an oxidizing agent. So if it is an aldehyde, it will give a positive result. But if it is a ketone, it give a negative result. So acidified potassium dichromate can distinguish between aldehyde and a ketone. Yeah. The correct answer is 2,4-dinitrophenyl hydrogen. I'm just explaining the options because we want which does not distinguish, but this can distinguish. So it cannot be A because the question is which does not distinguish. Acidified potassium dichromate can distinguish. Same thing, Phalling or Benedict solution, it gives a red precipitate. It's blue solution. If it is an aldehyde, it will give a red precipitate, but with a ketone, it does not react. So we can distinguish using a Phalling or a Benedict solution that whether it is an aldehyde or a ketone. Then we have a lithium tetrahydrodualuminate. Lithium tetrahydrodualuminate, it is a reducing agent. It is not even, it can reduce both of them, aldehyde or a ketone, but it is not a test the presence, it does not confirm the presence of the carbonyl compound, because even the, if we have like example, a carboxylic acid is there or we have aldehyde is there, it will reduce them. So this is actually a reducing agent. It's not the cannot confirm the presence of a carbonyl group, the lithium tetrahydrodualuminate. So what we are left with, we have 2,4-dinitrophenyl hydrogen, because 2,4-dinitrophenyl hydrogen can react with both aldehyde and a ketone, and it will give a orange or a yellow PPT or yellow precipitate. So we cannot distinguish which aldehyde or a ketone. We have to check the melting point. Is it clear? The correct answer for this one is B. Question 9, any doubt? Question 10. Question 11. How 10 in 10, how is option C standard? The definition of a standard enthalpy, the question is which does not represent the standard enthalpy change of atomization. In standard enthalpy change of atomization means when we produce the atom in a gaseous state. When 1 mole of atom is produced in a gaseous state, that energy which we supply we call atomization. So here you don't have to bother about the reactant. You have to check the product. Here 1 mole gas, yes, it is standard enthalpy change of atomization. Here 1 mole gas, yes, it is standard enthalpy change of atomization. Here 1 mole and a gas, it is also standard enthalpy change of atomization. But this one is not, it's actually for 2 moles, so it is twice the enthalpy change of atomization. 2 times atomization, not single, it's multiplied by 2. Question 11, any doubt? Question 12, any doubt? Question 13, any doubt in question 13? In question 13, which sequence shows the molecules in order of increasing the boiling point? So what you have to do to understand the boiling point, you have to first recall the idea about the intermolecular forces, the force between the molecules. We can have a hydrogen bond, we can have a dipole force, we can have a dipole-induced dipole forces. And the dipole-induced dipole forces increases as a number of electron increase. So the molecules which are given to us, we have water, we have bromine is given to us, chlorine is also given to us, and we have methane. So what kind of intermolecular force H2O will have hydrogen bond, which is the strongest type of a bond intermolecular force. So it means that we can have a rough idea that this should have the highest boiling point. So any option which is the H2O is the highest one, that should be right. Then when we check bromine, chlorine, and so what kind of bonds are there? These are the non-polar molecules. If a non-polar molecule, they will have dipole-induced dipole. So all of them have a dipole-induced dipole. Then the dipole-induced dipole forces increases as a number of electrons increase. More electrons means stronger dipole-induced dipole forces. So when you check CH4, carbon is having 6 and hydrogen is having 1 into 4. So total 10 electrons are there. For a chlorine, when you see chlorine is 17. So 17 multiplied by 2, it will make 34. Here, this is 39 multiplied by 2. So it will make 78. So which is having the higher number of electron will have the high boiling point. So the order will be CH4, which is having 16 electron, then Cl2, which is having 34, then 78, and then the water because of the hydrogen bond. The CH4 does not have a permanent dipoles because the difference in the electronegativity of a carbon and the hydrogen is very small. So actually it's a non-polar molecule. It is not affected by the electric field. So the non-polar molecules have dipole-induced dipole forces. Question 14, any doubt? Question 15. In question 15, which is not correct about ice? Ice has a lower density than water. That is the right statement. That's why you have seen if you are adding the ice into a container which is filled with water, you will find the ice float. So it shows that the ice is having a low density than a water. So this statement is correct. H2O molecules are further apart in ice than in water. That is also right because see, density is mass over volume. For the same mass, for a constant mass, if the volume is greater, the density will be low. That's why, like example, because in a ice, a molecule of an ice, the water molecules arrange themselves in a 3D structure, which have a maximum like a space is there as compared to when they are in water state, like liquid state, I mean, then they are closer to each other. They can overlap. But in a solid state, they have a large space between them, so the volume is greater, density is low. So H2O molecules are further apart in ice than in water. That's right. That's actually it's supporting this first statement itself. HOH bond angle is same in ice and in water. The HOH bond angles and the last one, H2O molecules in ice are held together by a hydrogen bond. So that is also true because when hydrogen is bonded with the most electronegative element, such as fluorine, nitrogen, or oxygen, there is a hydrogen bond. So the correct answer that HOH bond angle is same in ice and water. If these bond angles were same, it means that the density should also be same for the molecules. But they have a different bond angles, like the molecules of the water, H2O molecules in water, a liquid state, and H2O molecules in the solid state. Their bond angles are a bit different. That's why in a solid state, it has a different density. In a liquid state, it has a different density. So that's why C will be the, uh, like C is not correct. I mean, like the bond angles, when they talk about the bond angle depends on the type. I mean here, look, two things are there. One is a bond angle. Another one is the geometry of the molecule, like arrangement of the molecule. The bond angles are same, but the arrangement is a bit different. Like in water molecule, it has two bond pair and it has two. So when we draw the structure, the HOH angle is same. As a result, what will happen in a liquid state, the molecules can come closer to each other. That is why water in a liquid state is having a high density. But the same thing when OH, H2O molecules are there, when they are coming closer to another molecule, these bond angles slightly changes. And when these bond angles slightly changes, due to repulsion between the two molecules, the space between the molecule increases. So as the space between the molecules increases, as they are coming closer, so space between the molecule increase, so density will decrease. So which statement is not correct? The HOH bond angle is same in ice and water. That is not correct. They have a different bond angles. Is it clear? Question 16, part A and B. Any doubt? 16A or B? No doubt? Okay.